Then, firstly, I would like to thank Lokmanya Tilak College of Engineering. I would like to express my gratitude towards all the coordinators, all the working staff, and also the combined efforts of MESA for giving me this opportunity to lend my views over 3D printing. I really appreciate this kind invitation. And also, I really appreciate the participants' interest in this new technology. Really appreciate your efforts, guys. Thank you for this commitment towards your learning. Well, before we start, I hope you all are safe and sound and that you are doing well. Please skip this to be interactive session. I want this to be really interactive. You can use your chat box. If you can't mute your mics, you can use your chat box to interact with me. I will be watching the chat sections in real time, and by the end of this session, I will be addressing your doubts. And by the way, I have really something really interesting for you guys at the end of this session. So stay tuned till the end, and don't hesitate to ask any queries, any doubts regarding any of the stuff you found in this sessions to be asking what before. So in this session is going to be intended for all the people, right from beginners from zero to little knowledge up to experts and intermediates. Well, I'm pretty much sure by the end of this webinar, you can start 3D printing, or you can even plan 3D printing and additive manufacturing technology to be one of your choices for your professional careers. Or if not that, I'm pretty much sure that you can start 3D printing as a hobby right from the comfort of your house by the end of this session. And in any ways, you can just start a small factory at your desk by that. So guys, I want you to imagine yourself in a situation wherein you are working on a project, and let's say in between that project, there are some parts you need to be keeping them with you along with that project. So in some cases, what if those parts are misplaced? What if those parts, if any of those parts are broken? In that case, you need to go outsource those parts from someone. Either you can purchase, or you could have someone who can lend it to you. But what if the situation doesn't permit, like this unprecedented times doesn't allow you to get outside your house? So in that case, you need to wait for someone who could help you with this, and then you can start or resume your pending work or your pending projects. But what if I tell you that if there is some technology that is going to help you cure all your workloads, and without any hustle, you can try to manufacture whatever things you are misplaced or your broken things. So isn't that a great idea to have some technology besides you that can do the work as you wish, and your project doesn't remain pending? But that's where this 3D printing comes into picture. As you have your desired products when you want, how you want them, customized to just the way you're looking for, to meet your own specification. And this is what that makes 3D printing so special. Well, guys, welcome to the world full of opportunities and possibilities. So after the introduction and the technical presentations, we'll have definitely a small Q&A session. And I want to let you know that this is going to be a lot more than practical sessions, where I'm going to deliver you from some practical perspective of 3D printing, what work is going to be done in industries, how the work is going to be carried away. And I'm not just going to bombard you with theories and concepts. That's what you have been doing since years now. So let's get started. This is a small agenda which I would like to showcase you. We will be completing the introduction, then followed by an entire process workflow. And then I will be following you with the types, demonstrations, and applications of 3D printing, and which will be followed by the future scope of 3D printing in this world. So, to begin with, let me ask you some questions like, what do you think, what are the two different types of manufacturing processes in the industry? So if you try to recollect, somewhere in your lower grades, you have studied that the basic two types of manufacturing processes are nothing but subtractive and additive manufacturing. To begin with, there are a lot of other manufacturing processes like casting, forming, but to keep it simple, we will classify on these two categories. So subtractive manufacturing is going to be something like your end product is going to be manufactured from some raw material, and it's going to be layer by layer, cutted, sliced down, subtracted, so that you get your end results. For the students who are studying in second year, they might have worked with lathe machines. That's a perfect example of a subtractive manufacturing technologies. And some higher grade students might have been working with CNC machines. So that's another example of subtractive manufacturing. Next comes our additive manufacturing technique. So what is this additive manufacturing? Your end product, whatever you want to make, is going to be added layer by layer. So there is no way there is going to be a subtraction of any part in that product, and your end result is something of addition of the products, addition of individual parts or components in the product. So begin with, do you know what are some advantages of additive manufacturing technologies over the subtractive? Anyone in the chat section?
Material waste is less.
Perfect.
Complexity.
Great. Next.
Accuracy.
Yes, Kunal is saying waste of material is prevented. Yes, that's great. Cost of manufacturing goes down. The cost of manufacturing literally goes down by 95%. You won't believe the parts which are generated in additive manufacturing are ready to use in their final shapes. There are no tools, as in for the subtractive manufacturing, you require some tools to work for the lathes, CNCs, and no tools as such which are required. So the overall process planning which is going to be required is very less here. It's very curative, it's very less. Since I said there are no tools, the tools in the sense there are no jigs and fixtures, so no additional requirement of products which are there in your traditional methods. They won't be useful in this additive manufacturing. They are not used in any as such. So it's easy to make changes. Okay, if you are producing some components, some parts, and you want according to some customers' requirements, some changes, you can easily have those changes. Okay. So eliminating some constraints of the traditional manufacturing technologies, of the conventional manufacturing technologies, and bringing it up with innumerable benefits is what additive manufacturing is going to do. So to conclude about the advantages, we have less number of prints in here. So the cycle time of the products is going to be varying. Also, one interesting fact I would like to share with you. Today we are living in the fourth industrial revolution. Okay, that's what we call Industry 4.0. So basically, up till Industry 2.0, that's the second industrial revolution, when your French Revolution all started, preference was given to mass customization. Okay, so mass production was given a preference there. Now we have the people and we have the demands of the people. So are we going to fulfill the needs by those subtractive manufacturing processes easily and conveniently with those mass production ways? That's not at all possible. So additive manufacturing is going to give us innumerable benefits wherein we can gain an advantage of mass customization over mass production here. So that's where I want to say you, for more than a century, the products we design are constrained by capabilities of processes such as machining, molding, casting. And the economics of manufacturing have been limited by the need to invest in fixed tools and equipments, as I talked about. But additive manufacturing is going to cure all of those. So that's where we gain advantage here. To begin, let me take you, just out of curiosity, the history of 3D printing. So in 1984, after a lot of research and development, this person named Charles Descartes, who is now considered to be even the father of 3D printing, worked with a company named 3D Systems Corporation, and in association with that company, he made a first 3D printer which was using an SLA technology. By the way, SLA and all, these are stuffs which we are going to revisit in a few moments. I'm letting you know just in case. So the technology was patented, and that's where a new evolution of 3D printing arose. A couple of years ago, the two gentlemen who I've listed down here, this is a very famous picture which is taken from a article which was published in a famous US magazine. They say that machines are now capable of manufacturing 3D objects straight from drawings. So this was basically a great revolution in the history of manufacturing, and that's where it all started with. So to give an overview about additive manufacturing, basically defined, we can define it like it's a digital input simulation method in which computer-aided design or your CAD model is going to create solid or three-dimensional part through additive process, layer by layer. Okay, I am again focusing on the word additive process, layer by layer. That's where we are going to see in few moments. So your additive manufacturing technology is going to deposit layer by layer. It's going to add material layer by layer, and it's going to make a final product out of that. Coming up to the methods of 3D printing, well, I want to let you know that these are all the methods which are most primitive methods, most basic methods which are used in 3D printing technology. There are different ways which have came across, which we come across from these methods, but all these are primitively been derived by these basic methods. So the first one is fused deposition modeling, which is also called as FDM. So FDM stands for fused deposition molding. All in some countries they also call it as fused filament fabrication. Both are one and the same. In this method, what is going to happen? Your 3D printer is going to deposit material layer by layer, and that solid material is going to be deposited by a strand of heated nozzle. Okay, so in this method, a strand of plastic material is being pushed through a heated nozzle, and the nozzle is going to move in program patterns. Okay, yeah. So the nozzle is going to move with program patterns, which places the heated plastic strand in the shape of single layer of the part. And this is one of the most inexpensive type of machines which are available. Now, the basically nozzle is going to move in most of the common 3D printers. Now, nozzle is going to move in 2 axis. I will be explaining you that in detail in the next few moments. We can also print water soluble materials. We can also print different types of materials. And as you can see here, there are 2 nozzles which are loaded here. Okay, so there is also single, double, and there are even more than 3-axis nozzles which we can 3-axis nozzles we can achieve in this method. So to explain you in a little better way, I've added an animated video which will help you to make it realize how the process is going to take place. You can carefully see that the material is added layer by layer. It's completing the print. It's completing its first layer down. And when it's completing the first layer, just have a close look now. Look, the nozzle lifted itself up and it started depositing the material layer by layer in its next consecutive, or you can say corresponding layer. So this is what your fused deposition modeling technology is. It's going to deposit layer, it's going to deposit material by material, layer by layer, and at the end you will find this end product as a result of all these layers. I hope I am audible and visible. My screen is visible to both the ends. And if that's not possible, if there is any error, please let me know it. The second is the stereolithography apparatus, which we also call it as SLA. Where a stereolithography apparatus, to define, is a basic method in which a pool of liquid resin is heated up to a specific temperature. Okay, I repeat, up to a specific temperature. And then a projected laser moves throughout the liquid and hardens the resin at that point of contact. Now you can see, go to my right hand side, here there is a laser ejector which is going to eject the laser. There are some lenses which are provided just for the purpose of clarification about the intensity of the laser which has been marked. Here that is a mirror. This is a special type of mirror which is going to give direction to the laser in order to land that laser in this build tray. Okay, here this is called as your build tray, or you can also say is a build plate. So here your 3D printing is print is going to take place. Note that this method is completely opposite to the previous one. In the previous method, what we saw was the material was deposited layer by layer, and it was the bottom up direction. Here it's the top down direction, means your 3D print is going to be laid in a reverse direction. Okay, I will make you understand this in this animated video. So this is a pool of liquid resin here, and a UV sensitive UV ultraviolet laser is put into that photopolymer resin. It is also called as a thermoplastic resin. So to get this thing understand well, I have also added an animated video of the same. By the way, this is a print which we obtained from a resin based printer. So here, as you can see, this entire thing is going to be that pool of liquid resin, and here it's the compartment, the elevator. Here this is going to be the mirror, and this is going to be the slider. The reason I will explain you. As the polymer is as the unit is filled full of liquid resin, and the laser unit is detaching it UV light, and it's falling on this 2D on this laser, it's going to solidify at particular context where it will land, and this solidification will generate in making a product from that particular resin. Now once this layer by layer, once this first layer is completed, what if the product is at a certain height? So there must be something which is going to allow that particular product to like increase the height. So this elevator is going to just decrease or increase the size of its height, and by that you can shift the height of that material. Okay, so here you saw that mirror. It's a galvo motor system which is used in this mirror. So once this first layer is been completed, remember the preference first is given to the support structures, because your complete model is going to be built in that support structure, and once the supports are being fulfilled, you will be going towards the part geometry. So once these part geometry and supports are built, the slider is going to go in one direction, this rotor blade, and it will shift the layer and clean the first primitive layer. So this process is going to be working in a cycle, and at the end of it you will get a 3D printed complete part, and this is how it's going to be lifted up. So this is your SLA, or you can also call it as the stereolithography apparatus. So also, just like the SLA, we have the SLS type of printing. The only difference is here we are going to use a powdered resin. Okay, you can't call it as a resin. The resin is in the part of powder. There previously we had a liquid resin. So in SLS, it's similar to SLA, but instead directs a laser in a 3D space, and it's going to harden a powder at contact point, and a laser is still used in the process to produce a solid part, but interacts with the powder, as I said. So here this is going to be your powder system, and your layer by layer your material will be adjusting your height by this process, and the laser which is used here is a little the laser is a little more sensitive. It's CO2 laser basically, and since it's a powder based resin, definitely you need to have a high power laser for this. So all this printing process is calibrated or it's monitored in a very uniform build platform, which is enclosed platform, so that outside moisture, outside foreign objects could not entertain in between, and they just can't you fail the 3D print. So for this purpose we are enclosing SLS and SLA with a build chamber. But in FDM, particularly in printing in PLA, we don't require any build chamber for that. So to explain you this in detail, here is another animated video. So this is the nylon resin. Basically we use nylon most commonly here. The mirror is again reflecting the laser in this particular section. Again, this galvo motor system. Your print is going to give it digital outputs, okay, inputs to this particular system, and by that inputs it's going to fix its coordinates. It will rotate so that the ray of that laser is going to reflect exactly those coordinates which your part is designed to have for. So once you're done with that part geometry, remember, if it's a powder base, definitely you will be having some waste generated at the top of that layer. So what is the waste which is accumulated here? How to remove that? The slider is going to be helpful in that case. The build chamber goes down, the slider rolls, it's going to collect all the waste and it's going to deposit here. That's the beauty of additive manufacturing technology. Any waste which is produced in the manufacturing process can be recollected, and again, this, which we don't call it usually a waste, it's an asset, so we can use it again while our next 3D printing processes. So unlike the subtractive manufacturing process, this is not possible there. So the collection container will collect all that unused resin, powdered resin, and again this cycle is going to repeat and we will get our 3D printed product. Now, as I said, according to our agenda, what is the design workflow? How 3D prints are actually taking place? So the basic steps in 3D printing are: first, the designer will sit, he will decide what to print, how to print, which software to use, and what should be the approach while printing. So first, the CAD file is created in your system. Then the CAD file is exported to a 3D printer, and your 3D printer prints that file, and your 3D printed object is, in front of you. But to be honest, this is not that simple. You have something in depth in between there, and in between this process, there are a lot of errors, and where there are errors, there is attention to detail which should be given to those parts. So to give a better explanation, I would like to share a very detailed design workflow which I illustrated in the way. The CAD model should be converted to a file which another third-party software, a third-party application can accept. And the role of your CAD model is to make a design of that particular product which you want, but in the native CAD format, okay, in that native CAD file. So it is going to convert it in some neutral, in some standardized file format, okay. Obviously, your slicing software is in some standardized file format, and this is where your STL file format comes into existence. So .stl stands for Standard Triangulation Language. It's one of the universally accepted, most appreciated, introspectively and individually accepted file formats for the nations. Why? Because STL has the capacity to, inbuilt extract most of the inputs, even if there is very complex or not so complex organic geometry. So STL is going to do the work very well. Otherwise, there are a lot of other file formats like .obj, .object file, .amf, .additive manufacturing file, .3mf. So there are n number of file formats, but STL is the one which is going to be preferred. So slicing software is going to slice that STL. Okay, first step, CAD model to STL. When the STL is converted, the STL to the slicing software is going to slice. For the time being, just hear the word slice. I will explain you in detail in this. So the slicing software, after slicing that model, is going to convert in some other format, and that format, while slicing, is going to generate some tool paths. And these tool paths are nothing but those paths in which for example, if it's an FDM printer, the nozzle is going to move in those constricted parts or those decided parts according to the slicing software, so that your end result which you want should be your final 3D printed product. So that tool parts will be generated, and the slicing software is going to be converting that STL file to a .G code file. So .G code is your generalized code. Just in your CNC programming, you have your M codes and the G codes. So the same way, it's going to categorize it in some G codes, and this G code is going to be a standard code which your 3D printer is going to understand. Okay, the 3D printer is not going to understand your CAD file. Okay, in whatever software you make it in any software, it's not going to understand your STL file. What it requires is a G code to understand, to read. So that's a basic 3D PDF, you can say. Just as your normal printer, inkjet printers, any printers is going to interpret your 2D prints, so the PDFs or anything, such that in the same way, the G code is going to interpret, the 3D printer is going to interpret the G code. And once the 3D printer interprets the G code, it's going to make the model as per the design, and the 3D object can be taken out of the 3D printer. So this is a very basic workflow, what happens behind. Coming towards the materials, one of my favorite topic to talk about. The first very common material used is ABS, that stands for acrylonitrile butadiene styrene. So ABS is a very useful material in the 3D printing industry because of few reasons. It's going to melt very easily. It's going to have a little more temperature, more melting temperature than the PLA, but again it melts easily and it prints easily as well. It's durable and of a certainly higher quality, and you get finished parts really good. Also, a point to remember here is ABS is going to have a very great high glass transition temperature, that is your GTT. Is my voice breaking?
No.
Okay. So ABS is going to have high GTT, and due to that, it doesn't soften easily as PLA. Coming towards PLA, it's one of the widely used 3D printing material, most commonly used, extremely widely used in all the countries. You can see these granules of some material. Okay, these granules are nothing but a finished product of a raw product, and these raw products are nothing but your corn starch or some old sugarcane rush which are dried dried very well, and you make these granules out of them, obviously with some processing. So to say this, it means that PLA, or you can say polylactic acid, is going to be a bioplastic or a biodegradable material, right? So if it's a bioplastic or a biodegradable material, it's not going to harm the environment to that extent. And as a result, this material is widely used in the additive manufacturing technology. More reasons: the polylactic acid is going to soften at a temperature which is easily to control. Its melting point is about 185 degrees Celsius. Okay, so the fumes which are produced in PLA are very less, and they are absolutely no toxic. Whether you cannot even see those are negligible. And this is the important. If the 3D printer doesn't have optimal ventilation, so if you don't have a build chamber, so this is very important. ABS, if you are printing it in a 3D printing farm and there are a lot of printers, you can get some senses of fumes which are some kind of toxic to our human body. Coming to the third material, TPU, that is thermoplastic polyurethane. The 95A which I have written here is the grade of that particular material. So TPU is also not so widely used, but the material is used at a particular point of application. Now, why I said this? Because this is a flexible material. Remember the sole of your shoes? It's a little flexible. It regains its shape after compression, after loads are applied. So similarly, TPU is that kind of material which is used, which regains the shape. Okay. Point to remember here is most of the 3D printers can print PLA. Most of the local 3D printers can print ABS, but for TPU you require industrial printers or slightly top of the line printers. Last material is nylon. This is going to be a product specific material where you have some functional 3D prints to test. Some prints wherein you are using it for functionality testing, like there are real environment situations wherein loads and external forces are going to apply on your product. So that's where nylon comes into existence. It's a very you can say rigid and less brittle material. So the strength characteristics of nylon makes it very useful for such point of applications. The cost of the material is a little high, and due to which common people cannot afford printing always with nylon. And you have to use some specialized 3D printers for printing nylon, because the temperature is going to be 263 degrees Celsius, the melting point. So this is all about the basic 3D printing materials. I have demonstrated you this, keeping in idea about the FDM process of printing. We'll talk about the raising part later. So the basic terminology before heading towards the practical sessions I want to share with you is the 3D model. The 3D model is basically your CAD model which you are going to create. We will have a practical hands-on experience on that too now. A 3D printing resolution is something you can say that how accurate your 3D printer is going to print your particular product. So that's where your 3D printing resolution comes into existence. A 3D printing volume is your build volume, a chamber wherein you can have your limits to print the model. Your filament is going to be in your FDM printers material, and your resin is going to be SLA or SLS printers material. So filament is an FDM printers material which you call, and the material which is used in the SLS or SLS is going to be resin. Layer is the minimum distance that the nozzle is going to shift to make the next consecutive field, the next consecutive layer to work upon is the layer, and layer height is that distance. Build tray or build plate is going to be that platform where your 3D print is going to be where it's going to be stored. I talked about the file formats. They are STL, OBJ, that is dot object file, .3mf, .amf, that is your additive manufacturing files, and these are variety of file formats which are used, but we will be focusing over the STL. Reasons I've explained. Infill is nothing but the percentage of material which are present in your 3D print product. So if I say a product is having 80% infill, I mean to say the product is only having 20% of vacuum space or void space in that. Okay. Supports, one of the very important terminology in the field of additive manufacturing. Supports are required for your products when you have overhangs in between. Okay, and that too overhangs which are at an angle of 45 to 55 degrees. So all your 3D prints are not going to require supports. There are some products which will require supports. Then at the end I will show you that. So what's the importance of this all which I have explained you? These are all the basic stuffs, but I want to highlight this sixth point, that is layer height. The layer height is going to determine how good your 3D print is supposed to be. For an instance, if I'm saying that I've kept the layer height very less, that means your 3D print quality is going to be very high, definitely at a cost of investing more time for that product to manufacture. To explain this, I have one image in front of me. One amongst this is a injection molded part, and the other is a 3D molded, 3D printed part. So come on in the chat section. I want to know which amongst this is a 3D printed part. If you guys think the left one is 3D printed, type L in the chat section. If you think the right one is 3D printed, type R. So Meir is saying the left one is 3D printed. Kunal saying both, left one. Suraj saying both. Okay, most of the bottle caps are injection molded, but this is a very special structure. Definitely one amongst this is 3D printed. Not both. Come on, I want some more people to try. Tanmay is saying right. Sharvil is saying left. Sandesh is again saying left. Okay. So we have a. Okay. So here's a mixture of all both the answers. So you can see here, the right one is 3D printed part. This is because why you couldn't figure it, because the layer height which was kept while printing this was so small that a normal human cannot make whether it is a 3D printed or whether it's an injection molded part. But somewhere you can see here the material has left behind, the nozzle has left behind some material, and this needs to be cured. So after your 3D printing is done, after your product is formed, there is an additional steps. Not every time, but most of the times required if you want a very best quality of product to be formed from that. And that process is called as post-processing, guys. Now this post-processing process is different for different types and methods of 3D printing. So the first post-processing method is removing your supports if there are any. Okay, if there are any supports which are attached to your part, removing it with the help of spatula, with the help of a stick knife. So these are some ways you can remove the supports. Second, there is cleaning process which is done. Cleaning can be done with the help of a lot of tools which are available. You can use isopropyl alcohol. You can use this acts as a very good agent for cleaning. There are fixing. Okay, now let's take an example. If your build tray is falling short to print an entire product, what you can do, you can slice the model into a half portion. Then at the end, you can combine those both models so that your final product can be achieved from that. So this is again a post-processing way. Okay, you're cutting down the model into two different parts, and at the end, you're joining it, you're clubbing it together for getting an end result. So that's even a post-processing way. Third one is hardening or curing. That's again very important. Where hardening is concerned, you are using some materials, external agents, to some products like nylon, wherein your surface quality is required to be very smooth. Surface finishing can be achieved. The fifth one, surface finishing can be achieved by using methods like sanding. You can use different grades of sandpapers. Coloring, again, you can use, or you can say, some painters use their color sprays, and by that they can color those 3D printed parts. No, because not necessarily that all your material is going to be with the same color, right? Whichever you desire. UV synthesis, like, this is a very important point I wanted to share with you. Now there are some resin-based printing processes, where is like SLS or SLA, wherein there are some products which are 3D printed and the supports are sensitive and are, you can say, purposely put there in such a way that this supports needs to be post-processed with some UV synthesis process. What happens is, if you keep that final product in your sunlight, the post-processing will automatically take place, and your final result which you want, which you expect, is going to be achieved. Now this same process can be achieved artificially, wherein you can keep that product in a container and UV lights are going to be bombarded, and your product will be in the final quality whenever you want. PVA is such kind of material which is very sensitive, very soluble to water. So some printers also have this facility to print supports in PVA. So PVA, when you keep in still water, is going to dissolve, and when your material is dissolved, the support material is dissolved, you will definitely get your end result from that. So a lot of theories now. Let's understand it practically. To begin with, I hope my screen is visible on both the end, right? Can someone confirm it? Yes. Okay. Thank you. So yes, here sir. I have. Okay. So here I have opened a random part. I have designed a random part. A lot of you are asking which 3D software to go with, like which software to follow, and which is easy to for 3D printing or for any processes or for any designing field. So my answer to all these questions will be, your software is not going to matter, okay? Because what's important is your technical knowledge behind it, your designing skills behind that, your particular approach to your problem, your design intent, the way you think, that's important. And software is merely just a tool, right? So here I am using Dassault Systems CATIA. I have designed this part to let you understand two basic fundamentals of 3D printing. First, the orientation. You can see the part is designed in such a way that there is a curvature here, and it's completely flat. It's completely flat at this surface, right? Now, how many of you can visualize that how the part could be oriented in our build tray so that we get the best quality finish in less period of time, and we also save our material, we don't waste our material in the support. If you think that this part can be printed keeping the orientation, keeping this surface at the base, then you are completely right. This is what a lot of people at times fail to understand. your orientation is going to be one of those important aspects wherein your 3D printed product is going to affect your manufacturing cycle. Okay. Now this was really easy to understand with. So as I said, a part which is manufactured in a CAD software needs to be converted into a STL file. So this process is going to be similar for all the softwares which you will be using. I'll be using an STL file format, and then I will be saving it at a particular disk of mine so that I can use a third-party application and I can import this file. But a variety of softwares are going to give you some more control over this design. Let's take an example of a software which you are very familiar with. This is the Parametric University's Creo 5.0. I will just open a particular model. Well, this is something I reverse engineered a few years before. You can see there is a wrap command which I've used here, and this has created a twisting effect here. So this some sort of twisting effect is what making this a little complex geometry, right? Now to orient the part, we need to decide how to keep the which surface to keep as a base. So definitely, if you think that this is the surface which can be chosen for base, then you are right. Why? Because that's a thumb rule. Like whenever printing a part on a FDM printer, the model should be oriented such that the layers are perpendicular to the direction of stresses that will be placed on the part. So assuming that this will be the direction of stresses, obviously the gravity is going to be acting on each of these layers. So this perpendicular direction is going to be the best suited orientation for this part. So again, for this process, converting into an STL, I will choose file, go to save as option, save a copy, and then I will probably rename it, give it a new name, new file. I will be choosing a drive to store that, and then I will be choosing a stereolithography file. So look, this is the STL file. I selected it, and here we get some more options. First one is the file format. So STL is classified into both binary and ASCII, where ASCII is going to capture high details of that part, and binary is a normal version of that STL. The two options which are available here is tessellate with steps, and tessellate part and components with proportional chords. I will just select the first one since this is supposed to be a normal part and this is not an assembly, wherein the both options are used for a variable assembly size. Okay, so I will select that. I will save OK, and I will just save that part. Look, are you able to observe something here? Can you see this mesh?
Yes.
Okay, so this is something called as an STL file, wherein your 3D wherein your CAD file was converted into small layers of triangles, small triplets of triangles, with each single triangle is called a facet. It's similar like you can say a cell is the most smallest and functional unit of a human body. Similarly, a facet is a small functional unit of a STL file. So at areas where there is slightly complex geometry, look, this is turning over as some organic shapes here. So the facets have arranged themselves in such a way that they find triangulations even in that particular corner. Have a look here. So this is the beauty of STL. In any other file formats, you cannot extract the parent properties of the CAD formats in as good as you can. Okay, so this was an example of Creo. Let's have a look at some more advanced software. So I will be opening a part. This is basically a model from 212 Tobis Model Monday contest. Okay, so if you can see this model here, I want you guys to just visualize this from all the angles so that you come to know that here there is a slot which is having a cut extrude. There is some sort of circular cut extrude here as well. Rest is a normal geometry. Now, how can you orient this part? By keeping this as the face at the base, or by keeping this. First one, if you think, put in the chat section if you think the first one. This, put in the chat section 2 if you think this should be the base. If you think first, then this is the first one. Second, then this is the second one. Okay, so Manda is saying second, Riddhi is saying first. Okay, so again there are a mixture of answers getting here. Okay, so now let's understand it with some more clearance in your mind. Look now, this part, if I kept orienting it, keeping this as the central base, you will only have a section this where your support needs to be used. Okay, but if I oriented this, keeping this as a base, there will be two such instances wherein you will be requiring supports. First one is this, and second one is this. So for a manufacturing designer and a manufacturer, it's very important to understand that the best possible orientation of your part file is going to give you less print time, and that is going to decrease your manufacturing cycle, going to prevent more material from being wasted on supports, and at the end, the number of supports, if the number of supports are increasing, definitely your post process is also increasing. So this also reduces your time. So the ones who said first were correct. This is supposed to be an idle print orientation. Coming back to again the same format, I will select save as. I will select a STL file. Okay, so when I go to options here, I have some more control over the features in this particular software. Selecting the file format to be STL, importing, outputting it as a binary file, keeping the units in millimeters, I will have the option and my liberty to control the type of resolution I want. Suppose I want a custom resolution, I will click here and I will put the tolerance angles and the deviation tolerance values here. Or if I want a really great quality, I will choose the coarse customs here. Note that if you are going to export it to a third-party slicer software, definitely all your settings will be overridden, and the settings of that particular software is going to be there, and your G code will be generated as per that settings. Okay, so these are those options which we get. Coordinate, we can select that the default is only, and I will select OK, and I will just choose at whatever drive I wanted to select. Note that some features, some softwares also give you an inbuilt module like Fusion 360 Cam. They also give you an inbuilt module of checking how your part is going to be 3D printed. So right now we are into additive manufacturing, so we will be focusing on the 3D printing perspective. Otherwise, CNCs, for CNC there is some other module. So I will be going here, file, I will select print 3D. You can also get this option from the search command. Then the software will ask you to select a printer. Okay, now that we are not using top of the line printers because Dassault Systems, SolidWorks have managed some great printers here, we will be choosing a custom printer. And for those who said the first one was the great ideal orientation, I will be choosing the bottom of the model to be this. Automatically a build environment is going to be created here. You can see the red one is your build plate. Your model is situated inside. This entire chamber is your build module, build volume, and the more options which we are getting here is this option is orient to fit. If I orient to fit this, it will automatically going to be oriented in the best possible direction we can achieve it, so that the printer is going to print it very well. And if I scale to fit, this setting is where, because if you want to just hold it in your hand and you don't have any dimension concerns, you cannot use this, because if I click here, the model is going to scale it at the same size of what the build plate is going to be. So I can even scale it down or scale it up. Note that if I'm scaling it up, here there are some cause of error, and these are nothing where the software is trying to illustrate me that these are some instances wherein your model is getting away outside from your build tray, and that you need to work upon that. So I will be reducing the size here. Fit. Job quality as per as you want, draft, medium or high. I will choose medium. And here again the infill percentages. So infill is what, how much volume of material you want it to store inside. So I will by the way, ideal infills are 10%, and if you are printing some parts which are subjected to external loads and forces, then you can go with 50 and 60% infill. Okay, so I can save a STL file format and I can save a file wherever I wish to. Okay, so this was all about the CAD model generation and converting that CAD into an STL. Third, I will be talking about slicer software. So there are a variety of slicer softwares available out in the market. One of the best one which are available is Ultimaker's Cura. Well, Ultimaker is one of the biggest companies in the names of 3D printing and additive manufacturing technologies. So all softwares which are available in the market are basically of the 3D printing manufacturing companies. So if it's a very renowned company, it is going to definitely have its own software. For example, Formlabs is one of the best 3D printing printers company. So Formlabs have the Formlabs Preform software. You have Ultimaker's Cura. Markforged has their own software. Prusa printers even have their own software. So the reason I choose this is because of its neat and easy to use interface. So its UI is very simple. This is going to be your build volume. The one here below is your build tray. Note that when 3D printers were manufactured, coordinatively, all the printing companies decided to put their origin point in the front left bottom. This coordinate point could be changed according to your interest wherever you want, but it's advisable and it's best to keep it here only. So from here I can open a file which I want to slice. I can choose a 3D printer from a varieties of printer which I have. So currently in my working space, I have these two printers. This is a slightly small, and this is a printer with a little big bed size. So we can again shuffle back from those. Remember the material selection I told, it's one of the most important factor in 3D printing. So if I am changing the material, you need to give the command to the 3D printer that the material is changed. You cannot simply change the material by removing it from that extruder, and you can by just putting it. You need to also give it a command here. Well, 0.4 mm, remember this point, 0.4 mm is the standard nozzle size which is available in the market. Note that some big printers also have larger nozzle size. You can customize the way you want, but 0.4 mm is the standard nozzle size. You can add some additional parameters like the quality which you want. The best and easy way to increase the quality is by decreasing the layer height, so you can get a very superior quality. So based upon the quality, there are 4 such things. I have also added some external profiles which I find it very handy. You can also try to align a support here. So let me demonstrate you by importing a model. Okay. So this is a organic model. It's an organic shape of an elephant, and these are voronile patterns here. Now to slice this model, the option here, this is going to convert it in the STL file into a G-code file, and we are able to have a total control on the parameters which we want to set itself. So for an instance, I want to control the speed in which it's going to print. So the less the speed, it's going to print it very well. The more the speed, it's going to at the cost of decreasing the time, it is also going to decrease your quality as well. So if I am selecting normal supports here and the quality to be a standard one, I'm slicing it. The software is interpreting the file and slicing it to get a best G code from this particular model. Here is an option to preview how the model will look when it's 3D printed. You can get a real-time view of that model here. And if you want to connect a camera to your model, you can also do that. You can also monitor your 3D printing process with the help of a camera. So here's how it's going to preview like. The red one, the areas in red are those areas wherein the model is sliced perfectly. The blue one here are the supports. You can see 298. This is a number of layers which the model is going to create at a standard quality of 0.2 mm. Here is the printing material which is consumed, the cost, and here is the time which is taken. Alright, so if I just slow it down, you can see here how the material was deposited layer by layer and how you are getting a nice final product out of that. So if I am on my 271th layer and if I want to wisely look, so this is your nozzle which is moving, you can see, and it's depositing the material layer by layer so that your final product is taking place here. So that's how the process of 3D printing takes place at the back end. So I will try slicing some other models too. Okay, this is yet another file. So you can just hang in your earbuds right here. So let's slice with the same parameters. For the less complex part, the slicing time is also going to be decreasing. Now since it's a small figure, your time is just 2 hours. The amount of material which is going to be invested here is 12 grams. And here 9.63 is the cost of printing. As I said, supports are only required at an angle of 45 to 55 degrees. So I've kept an average of that. And the only supports which are required here is here at the end. So this is what 3D printing takes place at the back end, how your model is going to be manufactured, and after manufacturing it's going to be look like the same way it's showing me right now. So coming back to the presentation, I wanted to demonstrate you with the help of an animation, the basic 3D printer. So this animation I created with the help of SolidWorks Composer. This is your nozzle, your build tray, and this is a typical FDM printer which is available out in the markets. This is entire your build structure. Your stepper motors for each axis, because it's 3D, then definitely it's going to have X, Y, and the Z axis. This is your lead screw. This is your extruder, and here your nozzle is going to be situated. For the convenience of demonstration, I didn't use a strand of that plastic material, your filament. This is your control unit, this is PSU, your power supply unit, and this is how a basic 3D printer is going to be loaded. Here you call it as a spool holder, basically for storing your filament and feeding it right from the burden tube to the extruder here. So this is how a typical 3D printer looks like. If there is a more larger bed size, then your structure is going to increase so that it requires high durability. And this is how a basic FDM printer is going to work like. So here are some projects which I want you guys to wanted to demonstrate. So the need of actually demonstrating this was you can use 3D printing as a day-to-day hobby with uh, so your as a day-to-day hobby with all minimum resources and less number of time. This is a customized laptop stand. Here is a rendered model of that, and here is the actual model which came out, and it came out to be a really nice model after 3D printing. So here is the point of application. You can just put your laptops over it ideally, and without us, we can use them without any strain on your eyes. So the purpose of demonstrating you instead of some complex mechanical core projects, the DIY projects, that's your do-it-yourself projects, are going to demonstrate that you can use 3D printing as a hobby even at the comfort of your house, and you can establish a small factory at your desk. The second one is it's a customized remote case. Basically, a remote is something I never found where I need it the most. So here, as I said, the first method is going to be creating a CAD file. So this is how I designed the case in PTC Creo. So once the case was designed, I imported that to that STL software, Ultimaker's Cura, so that it's going to import the STL and convert it into a G code, which my 3D printer will read and print it. By the way, I manually took the dimensions at the point of my application, and by that I customized it. So this is how the end product is going to look like, and I just forgot to remove the supports in here while clicking the picture, but it exactly matches the requirements, right? So this is yet another example of a customized product you can 3D print right at the comfort of your home. Next one is a customized mobile stand. Again, the same way I designed it and 3D printed it in the best possible way from using the best possible settings. The fourth one are some functional prototypes. So this is a picture which I took from my customers or social media. Actually, this is a functional prototype of an element. If you are belonging to any SAE or BHA team, you might know that this is a differential bracket made up of aluminum 6061 T6 material, and the people who are working with the teams, they need to check the dimensions, the tolerances, the fits of the parts, and hence 3D printing is of wide applications there. So this was completely manufactured in nylon, and they were testing it like durably. This is a Pythagorean cup which I tried to design and print it using my FDM printers, and it really works. Again, a tablet holder which is very convenient if you want to watch series at weekends. So again, you design it, you print it at your house, and you use it at the way in which you want it. This is another yet an animation of an iris mechanism. So basically, this iris mechanism was printed the same way in one shot by a single FDM printer. So there are no assemblies. This is a single part which was printed as per the design. This is another customized product of a headphone stand, which we can generally tend to use to store basically get your headphones to. So these were some of the products which I wanted to demonstrate with you guys. Now, when it comes to monitoring your prints, it's possible? Yes. Your 3D printers, some advanced 3D printers also have a Wi-Fi card between them, and those Wi-Fi cards is going to give you the capability to view your 3D printing process live with any of your devices. Coming towards the application, you can see a Lamborghini Aventador car here. Most of the parts before the actual model were 3D printed and tested. So there was a lot of complex surface modeling where designers put in a lot of efforts, and then by just manufacturing into right place is going to cause them a huge loss if there is something wrong. So 3D printing can be very beneficial there, wherein you can just make a prototype, test it. If it works, you're sure you can go with the final product as well. So that's where functional prototyping use into your picture now. Manufacturing tools, you can also have some customized tools with you. You will be shocked to hear that 3D printing is also used in the food and fashion industry. You can have your chocolates 3D printed with your names. So there are 3D printers which also prints food like pancakes, chocolates, etc. In the medical industry, I am pretty sure you have heard the a few weeks ago that entire vein was 3D printed and it was custom fitted on a particular as an implant at a particular patient, and it really worked out to be great. You can also put in artificial arms for disabled person. So these are going to give a great edge over those traditional uh, plaster POP arms. Bioprinting tissues is also a very great advantage of 3D printing. This is extensively used there. You can also have medical equipments to testing for testing purposes, or you can also say in the case of wherein if you want to go to a dentist, you have the models of your teeth and the jaw. So for demonstration purpose to new candidates who are into the field for for life surgery, to give simulations of life surgery, you can use 3D printing there as well. So the applications of 3D printing, if I go on listing, the sky is the limit. You can use in the automotive and aviation sector as well. Artists can create and redirect models basically in architecturings. Here, this is basically been created by resin 3D printer. As I said, you can 3D print chocolates as well. So there are some advanced 3D printers which are going to print the name on your chocolates as well. These are additional airways to give, just like a heated nozzle is going to deposit material of that chocolate, it's going to cool down so that it solidifies as quickly as possible. So as I said, in the medical industry, physicians can use 3D printing to just demonstrate the teeth and the bone grafts. You can also 3D print tissues. It's called bio 3D printing. Objects which are made from 3D printing, there is the sky is the limit. You can extensively use everywhere. For in case of shoe, I said you TPU is a flexible material which is again used there. Rubber, yes. So you can also customize your toys the way you want, however your child wants them to be. You can also get a great edge over your replacements of your broken parts if you have any, instead of going and buying it all the time. So the basic requirement is you need to be well versed with any CAD software, and you should be having a 3D printer in your locality also. So you can also design complex structures and get those 3D printed in no time, because all the complex structures cannot be modeled or cannot be manufactured with the help of injection molding process. For an instance, this part. So look, this is such a complex structure, but it is very well done with the help of resin-based printers. Animated characters, yes, it is even used in animated movies, wherein, for example, Sony Pictures was the first to embrace the concept of 3D printing to get characters in the movie Pirates. You can see this is a demonstration of an artificial arms for disabled people who can use this, and this is really a great edge over those traditional arms which gives you itching over a period of time. You can also do demand based manufacturing based upon your customized orders whichever you get. Here's another yet example. By the way, one more example of that. This is a product named Liberator. It was a completely 3D printed gun in the year 2003. It was tested, and yes, there were 16 parts used to make this gun. However, the bullet was made up of not a plastic, but it was from a metal nail. But yes, this was printed at one particular place, and this was designed at a one particular point, and it was printed somewhere else, and the point of application was definitely somewhere else. So future scope is of 3D printing, as I showed you, in the aircraft industry, in the manufacturing domain, in demand-based manufacturing, making complex structures very feasible and seamlessly possible to make it happen. So you can see a lot of news. You can see that there are 3D printed houses, there are 3D printed boats. Recently, yes, they made a world record. They printed an entire yacht in one single stroke with the help of 3D printing technology. Now, Dubai is enforcing some laws to to just stop 3D printing being extensively used or all over the infrastructures are being used 3D printed with the help of some concrete materials. You can see an entire satellite, a small satellite was basically 3D printed. So this was an extensive application of 3D printing. So at the end of the day, the question arises is, should you invest in a 3D printer? Yes, it's definitely a good investment. It's going to improve your creativity. It's going to educate children. The 3D printers are environmentally sustainable. As I said, the material is non-biodegradable, and yes, it's environment friendly. It's going to save a lot of time and money, and just for fun, you can do it as a hobby as well. So if you have any questions, you can drop it in the chat section, or you can ask me now. And the same meantime, I will have a look at the chat section now. So Kunal is asking, are these material harmful in nature as some of those produce toxic fumes? Yes, ABS do produce toxic fumes, and ABS is also a type of plastic. So it's avoidable that you don't use 3D printing with ABS in food industry. So basically to store food or any other product. Guys, if you have any doubt, you can ask in the chat section. Okay, so the inner parts of the hollow elephant geometry, that was a tedious job to do. If you are using some water soluble materials, then there definitely the parts which is going to be manufactured is going to have some post processing required. Basically, I'm talking about that elephant geometry. So it was quite a tedious job to do, but yes, you can do that. That opening and closing. So basically, if Anay is asking about the erase mechanism, that's very simple. You should just design it with keeping in mind certain parameters, that your angle should not exceed 55 degrees. If you are working on a very advanced printer, then your printer can also withstand that angle, and it can print easily at a overhang of 55 degrees. My printer didn't had that, so I kept in point that parameter. Otherwise, if it would have exceeded, then supports would have been deployed and on those sections, and as a result, it would be a tedious job for me to remove those supports and get my final product in my hand seamlessly. So, which material is used to print body part? Which body part are you talking about, Aditya? While if you are trying to say about bioprinting, if you are concerning bones, then there are there is definitely not these materials which are used. There are different materials which are composition of 2 or 3 materials, wherein your basic composition should be of zinc of limited amount, titanium, and the overall material which you will be using should be matching the same density with the density of your bones, if that's the concern. How did you gather so much knowledge? So this is just by practicing, learning. Basically, if you are having internet with you, then you are most powerful person in the world now. Yes, it is a great option as a career. uh, are there any specific rules or restrictions? There aren't any such rules, but there are some parameters you should keep in mind. This all comes in a completely different subject called design for additive manufacturing. So, Nufail Ahmad, if you want, we could also take a session on that. And if you like this today's session, you can give a feedback to the MESA community. and surely we could have some. You can get a deep dive into such sessions in future. So why Dubai is regulating 3D printed house? As we know, it is quite popular there. So they are not regulating 3D printed house. They are just putting some restrictions over the capabilities of 3D printing because they feel like this will increase the plastic intake in their country at a high volume. So they are just putting some restrictions. DMLS, yes, direct metal laser sintering. It's also a type of 3D printing technology wherein metal is being 3D printed. Again, it's going to be same like the selective laser melting, where SLM is a type of 3D printing technology wherein you will be printing metals. And the most commonly used metals in this are steel and aluminum. Yes, they are used in the aerospace industries with metals. Perfect. Which 3D printer do you have? Currently, locally, I'm having an Ender 3. That's the best 3D printers which beginners can buy. If you want to start 3D printing as a hobby and if you're confused with 3D printers which to buy, you can surely contact me. What is the average life of a 3D printer? Depends upon how robustly you use it. Otherwise, a normal 3D printer can definitely give you a great work for 5 to 6 years at least, I believe. How we can estimate the cost for 3D printing? So basically, there is a formula which you can follow. I would say you like there, you can consider it to be a formula. What you can do is you multiply the power which your 3D printing is consuming into multiply that with the cost of electricity per unit at your locality. So for an instance, if my Ender 3 is using 350 kilowatt of electricity, so 0.350 multiplied by my electricity usage is like 9 units uh, for art, so that will be approximately 3.75 rupees. Okay, INR. That's estimated cost of 3D printing a product for 1 hour. Okay, I repeat, that's for 1 hour. So you multiply it with the total time as you saw on that software, and you can get a final price of your product. If you are trying to replace a part, so is it possible to scan it instead of making it? Yes, Kunal, it's completely possible. In fact, there is a 3D scanning method wherein you can scan a particular part, reverse engineer it, and this is going to extensively save a lot of your time to model it manually. Yes, I will tell you where you can contact me. Come on, guys, if you have any other doubt, put it in the chat section now.
There are few doubts in the set.
Okay,
There
so
are few
can
doubts
you
in second.
okay, can you tell me?
Sure. Okay, there's a doubt saying just want. Is it necessary to have a core knowledge in maths?
Maths? No, there is no rocket science here. It's completely simple. You don't need to have that knowledge in math for operating 3D printing and coming into this industry.
Okay.
This 4D
Another question.
printing, yeah,
Yeah.
yeah. Next, please.
Please continue. Another question is recently I wanted to 3D print a prosynthetic finger. It is almost cost me 1,500 rupees.
Okay. So how can I help? Hello. Is there any doubts at that end? Yeah, so I just now said the cost of 3D printing will be depending upon the type of printer you are using, the material, keeping into consideration the parameters like your electricity usage at your locality. For example, if you are staying near an MIDC, the cost of electricity is very cheap there. And if you are using a printer which is registered in a locality which is registered as a commercial purpose, then the cost of electricity is more there. So it's completely going to depend. Guys, any other queries? Are there any internships or jobs in 3D printing? Okay, I will also come on that. So guys, for that one news which I wanted you guys to stay tuned till the end is we are launching a 3D printing detailed course and practical in-person sessions on 3D printing and additive manufacturing technology where you will be able to learn and get hands-on experience on the 3D printers, all the processes because here today I just demonstrated the workflow which was the basics. There is lot more to give a deep dive into the industry and you can easily avail that by enrolling in this internship. I will be sharing the details of that in the WhatsApp group which you have joined. So please don't leave the group. The internship will be in Mulund. So if you guys can come in person, that's great. Or we can also arrange in-person sessions there. So if there aren't any doubts, with the interest of time, I would like to end the session. Uh, thank you one and all. You were a very wonderful audience. Thank you, Misa, for giving me this opportunity. And yes, Kunal, if you want to contact me, you can contact me on the social media handles, mail IDs, and my LinkedIn. I am active, pretty much active here. So guys, happy 3D printing.